So we're going to sit down and try and make a quick video real quick to see if I can do it without burning myself. This is for Jeff Barnum. I'm also a Jeff, by the way. We're going to show you just a quick 1-2 on series versus parallel. So I've got a couple 4S lipo packs, positive, negative, red and black, same kind of deal. Now if you take these and you wanted to say make them parallel and keep it at 14.8 volts, you would be tying together the two blacks and the two reds. And what this does is basically combine the two packs and keep the voltage the same but double the capacity and also double the amps that it will put out. If you wanted to make these in series, you would be essentially taking the positive from one, the negative from the other, and hooking the two remaining wires together. And then in this circuit, you're going to keep the same milliamp hours, but it's going to be double the voltage and the same amp rating, C rating that it would be just one pack by itself. So this is now 29.6 volts versus 14.8, but it's still 5,000 amp hours and it's still at 50 C. So that's a real generic series versus parallel. So what you need to pull this off are a couple different sets of connectors. If I wanted to parallel these two packs and keep it at 14.8 volts, but it would essentially be 10,000 amp hours at 50 C, you're going to have to make some Y connectors, and it's basically a pair of males, and they will plug into your battery packs and make them into a single female that would essentially plug into your speed controller. If you wanted to make them in series, double the voltage, you're going to need a doubled up male connector, and that would go from the black of one to the red of the other and give you two your positive and negative, and it would be twice the voltage because you've now linked the packs together, or linked all of the cells in a row more or less. So I want to show you real quick how to put on one of these Castle connectors. They're tight and they spark real good. What I like to do, I've got a bench vise downstairs. I don't know if you have a vise or not, but you can get away with a couple of different things. I like to take and tin the connector first. And basically what that is just heating up the connector and putting some solder on the inside. And what that'll do is it will make a good heat conductor for when you actually put it on your wire. One of the biggest things that I've found so far is wire prep. Like this is what you get from Castle, and that is most likely not going to fit into your connector. This was a really bad hack job, but we're going to just go ahead and cut it off. Now you can use a pair of dikes or some really heavy scissors and kind of hack your way through that, trying to be good about making the end flat. Now while it's still in the sheet, you can kind of, in the excuse me, the sheath, you can kind of see that the end is all held together nice and tight. Now that would fit into your connector. So how do you keep that all together? Well, one of the things that I've learned to do, I'll just use some vice grips now because it's easy to hold it. I like to keep the wire always facing up. That means that the excess solder is going to drain down the wire versus draining out over the outside of the connector or into it or into your male end where it's supposed to spread and that kind of stuff. So what I'll do is I'll take and cut the end of it off nice and flat. And then I've got a soldering iron. I'm also going to be using a benzomatic torch. But good heavy soldering iron. This is a Weller that I've had for dozens and dozens of years, but you want something that gets good and hot in a big hurry. Got a couple different kinds of solder, the Radio Shack 6040 stuff, some stuff that I bought from Ace Hardware in a pinch. Just make sure it says electrical on it, and you want a flux core, and that'll help the solder wick into the wire. Real fine strands in these wires, so if you pull that sheath off right now, the silicone cover, that stuff just frays out, and that's how you get that junk connector that doesn't do you any good. So soldering iron's getting hot, melts the solder real good. Basically what I'm going to do is just make a bead of solder on the top of this wire and wick some of the solder down into it. You'll know that the wire is getting good and hot when you see that little bit of yellow flux start to bubble on the end of the wire. I don't know if you can see that or not, but basically you just put some in there. That's bubbling pretty good there. And that lets you know that some of that solder has wicked down into the wire. The other thing that you'll see is when you pull the soldering iron away, you'll watch that solder wick down in there and you get kind of a fuzzy gray instead of a solid silver. That lets you know that it was hot enough for the solder to get down in there. Solder contracts when it cools just a little bit anyway. So that's our wire that we've added solder to the end of it now. So basically what we can do, I like to use an X-Acto knife. You got to be careful not to push real hard. This wire is so fine that you can cut right through it with the X-Acto knife. But if you're careful, you can just score off some of that silicone and peel it back. Now what you've got is a real nice little end that's basically pretty stiff with the solder in it. The solder hasn't wicked in but maybe a 1/16 of an inch down the end, so you'll have to add more solder to it. But that's the size of wire that will fit down in that connector. So from here, what I'll do is heat that up again and add some solder to it. Once the soldering iron is hot enough. You don't want to push down on the end of it. You just kind of want to stand up against the side of it at this point. If you heat up that cable too much while you're pushing down on it, of course you'll spread it out with solder. Basically, I'm just working my way around it, adding solder into it. And that gets me a good stiff end to work with. And one of the things that you can do after that's cooled just a hair, you know, if you've got an edge that's pushed out a little bit or something like that, once it's got solder on it, it's pretty solid. You can actually take some pliers and stuff and kind of reshape that, make it more round or more square, or you know, whatever it is you need to fit it into that connector. And hope I'm not going too awfully fast. But yeah, so that way you've got a nice tight round connector end, or wire end for your connector. This connector I think has a little bit much solder in it, so it's not going right in there. These were actually what I pulled off of my dead XL in a big hurry. But we'll see if that'll just walk onto there okay. Nope, a little tight. So yeah, so here we go. There's the squeezing the wire trick coming into play right there to make it fit into these connectors. I usually don't do a whole lot of solder in the end of that connector, but I was in a pretty good hurry to get these off so I could get that controller sent out to Castle. So that's going to go in there okay.